Hey guys, welcome to volume day 1. You have been exposed quite a bit to the volume formula, and I bet you know it backwards and forwards by now. So during this unit, we're going to use what you know about volume, and we're going to apply it to some different real-life word problems that you might actually face, like what happens to the volume of a cuboid when we put something in it, like a rock, or how can we find out how fast water is emptying from a cuboid, or like maybe a fish tank, something like that. So let's get right into it with a quick review of the different dimensions that we need to find volume. So length is measured in centimeters and it's one-dimensional. Length is just one side of a cuboid. Area is measured in square units and it is length times width. Volume is measured in cubic units. Now let me slow down for just a second. When we measure area, what we're doing is we're measuring the number of, sorry guys, I had a little tech flub there, but what we're doing when we're measuring area is we're measuring the number of square units that make up a figure. And we just multiply length times width to find that. When we measure volume, we're measuring the number of cubic units that make up a figure. And so when we measure volume, we need to multiply length times width times height. So here's our height right here. All right, on your notes, you're going to write down area is the number of square units required to fill a figure completely. Volume is the number of cubic units required to fill a figure completely. And volume is measured in cubic units. What that means is that instead of writing centimeters squared like I do with area, for volume, I'm going to write centimeters cubed, or meters cubed, or inches cubed, or whatever cubed. But it's measured in cubic units. And here are some pictures of some cubes so you can picture this in your mind. Okay, so our formula is length times width times height. And let's just start off with a question. Laura uses 1 centimeter cubes to build a cube of edge 4 centimeters. How many cubes does she use? So in your mind's eye, let's just picture this larger cube made up of smaller cubes of 1 centimeter each. And it would look something like this. You'd have all of these cubes, and they would fill the center, and they would fill each edge. Oh, I forgot a line. There we go. And our question is, how many cubes does she use? Well, we could look at this and we could almost just count, right? We've got 4 along the length, 1, 2, 3, 4. We've got 4 along the width, 1, 2, 3, 4, and 4 on the height, 1, 2, 3, 4. And if we multiply that, we would get 64. So we'd multiply 4 times 4 times 4, and we get 64. We probably want to go do a step in between there and multiply 16 times 4. Okay, so our answer would be 64 cubes. Since we measured in cubes this time, we weren't talking about centimeters necessarily, so we would write cubes for our label. Now say we want to make a larger cube with 5 centimeters on each edge. We're still going to use 1 centimeter cubes, and we want to know how many we need. So now we're going to multiply. We've got 5 on the length, the width, and the height. And we're going to multiply 5 times 5 times 5. So we'll multiply the first two 5s together, get 25, and multiply that times 5. And we're going to get 125 cubes. Okay. Now, if we assembled our cube with all of these cubes that are each 1 centimeter cubed, so we've got 1 centimeter right here, 1 centimeter right here, 1 centimeter right here, then obviously this 125 cubes is also going to equal 125 centimeters cubed, right? Because each of these cubes measured 1 centimeter. But what if my cubes measure 2 centimeters each? And now we want to find its volume. So the question in front of you right now is it says this figure shows a solid consisting of 10 cubes of edge 2 centimeters, and we want to find its volume. Okay, so obviously the first thing I need to do is I need to find the volume of one of the cubes. which is not going to be 1 by 1 by 1. This time, we've got cubes with 2 centimeter edges. So we're going to find the volume of 1 cube first, and then we're going to multiply that by 10. All right, so let's substitute in our values. We've got 2 by 2 by 2, so we're going to multiply 2 times 2 times 2, and then we're going to multiply that times 10 to find the volume of the figure, because we have 10 cubes in there. And our volume is going to, of 1 cube is going to equal 8. 2 times 2 times 2 is 8. And if we multiply that by 10, we're going to get 80 centimeters cubed. All right, now, how many cubes of edge 2 centimeters are needed to build a cuboid measuring 10 by 10 by 6? Okay, let's visualize this really quick. If we have cubes of edge 2 centimeters and we want edges of 10 centimeters, so we want 10 centimeters right here, 10 centimeters right here, and 6 centimeters right here. Okay, let's just visualize what our cubes would look like. And so we would need 5 of them to go across this way. 1, 2, 3, 4, 5. 5 going this way. I realize this picture is not to scale. And then we would need 3 going this way, 3 rows to stack up, wouldn't we? So it looks something like this. Because we want 6 centimeters up here, so we would have 2, 4, 6, and we want 10 along the length and the width. So let's plug that into our formula, length times width times height. So 5 times 5 times 3, and we would need 75 cubes. So we would need 75 cubes, but our volume, if we were to measure that in centimeters cubed, would be different. It would be 10 times 10 times 6. So if we measured in centimeters cubed, let me write the volume. We'll rewrite the formula. Volume equals length times width times height. 10 times 10 times 6, and that would equal 600 centimeters cubed. Okay. Let's take a look at number 3. How many cubes of edge 4 centimeters are needed to build a cuboid measuring 8 centimeters by 4 by 4? Okay, this time we want 8 centimeters across the length, we want 4 centimeters across the width, and we want 4 centimeters high. Okay, well, if our cubes are edge 4, then we're going to have 2 put right next to each other down here, right? And then we'll just have 1 deep and then 1 high. So it would look something like this. So we would have 2 cubes right next to each other, and it would only be 1 cube deep and 1 cube high. So we'd have 2 times 1 times 1, and our volume would equal 2 cubes. Now, if we want to know the total volume of the cuboid, now let's substitute in our centimeters. Okay, so we had 8 centimeters there, 4 here, and 4 here. 8 times 4 times 4 would equal 32 times 4, which would equal 128 centimeters cubed. All right, let's write the formula for volume one more time. Okay, we're actually going to be writing this quite a bit in this unit. And now let's find the volume of a cuboid that's 1 centimeter by 2 centimeters by 3 centimeters. Okay, so we're looking at something like, it's in your notes, but it's not on my PowerPoint here. We've got 1 by 2 by 3. Something like that. Let's start with our formula, length times width times height, and then substitute in our values, 1 times 2 times 3, and that's going to equal 6 centimeters cubed. Okay, now suppose that we were given the total volume of a cube and the length and width. Is it possible to find the height with that information? How would we do that? Okay, so let's start with our volume formula here. Volume equals length times width times height. Now, if we had numbers for volume, length, and width, and we wanted to find height, that would mean we'd want to get height by itself on one side of the equation. So to get rid of length and width over here, we would divide that side by length and width. Whoops. right? Now, since our equation says equals here, we can't just divide one side of it. We have to divide both sides to keep it equal. So these guys would cross cancel, or cancel out, and we'd be left with height on our own over there. And we'd have volume divided by length and width over here, and that would equal height. So that's what we're going to do in the next couple of problems. Number 5 said the length of a cuboid measuring 5 centimeters and its width measures 10 centimeters. Its total volume is 300 cubic centimeters. What is the height? All right, so let's start off with our volume formula here. Length times width times height. And let's just start substituting in numbers. So our volume is 300 cubic centimeters. Okay, now we've got our variables filled in. So we want height by itself, so we need to divide both sides by 5 times 10. And these cancel out over here. And now what I have is, if we go ahead and do that multiplication over here on the left side, 300 divided by 50 equals height. We can cross cancel one of those zeros, and now I have 30 divided by 5. So 6 equals height. And I want to make sure that I have my label on there, and since I'm measuring in centimeters, it's going to be 6 centimeters equals the height. Okay, let's do another one. All right, now the base of a cuboid, ooh, this one's harder, measures 20 centimeters by 12 centimeters. If the volume of cuboid is 3,600 centimeters cubed, find its height. Let's do the same thing. Let's start off with our volume formula, length times width times height, and we're going to plug in numbers. So we've got 3,600. We should probably keep our units there, equals 20 centimeters times 12 centimeters times height in centimeters. Let's go ahead and get rid of the 20 and 12 on this side. Okay, those will cancel out and height will be by itself, but since we have an equal sign, we have to do the same thing over here. And I can multiply those out right now if I want to, but I actually I don't have to. I can go ahead and I can cross cancel one of those zeros before I multiply, and then I'm left with 360 centimeters cubed over 2 times 12, which is 24 centimeters squared, because that was centimeters times centimeters, but I forgot to write it there, equals height. And when we divide 360 by 24, we get 15 centimeters, and that equals our height. And that should just be a length measurement because it's just one dimension. All right, guys, for the last 2 minutes here, I'm going to run through this last problem that you have in your notes really quickly. It says, find the height of this cuboid with volume 175 cubic centimeters. Area of the shaded part is 25 centimeters squared. Okay, let's start again with our volume formula. Volume equals length times width times height. Now notice that length times width, that's the formula for area, isn't it? So we could rewrite that formula like that. Volume equals area times height. Whoops, there we go. And we're given the area of one face of this cube. So when I substitute in my values here, I'm going to substitute in 25 centimeters squared times height, and I'm going to substitute 175 cubic centimeters for volume. So now I'm going to do the same thing that I did before. I'm going to get height by itself. So I'll divide both sides by 25. They cancel out here on this side. And if we divide 175 by 25, we're going to end up with 7 centimeters. That equals height. All right, that's it for day 1 of this new unit. If you struggled with any of these concepts, please come see me and have a nice day.